Test organization. As we mentioned at the start of the chapter, testing is a complex discipline and different people use different terminology and organization. The Rust community thinks about tests in terms of two main categories: unit tests and integration tests. Unit tests are small and more focused, testing one module in isolation at a time, and can test private interfaces. Integration tests are entirely external to your library and use your code in the same way any other external code would, using only the public interface and potentially exercising multiple modules per test. Writing both kinds of tests is important to ensure that the pieces of your library are doing what you expect them to, separately and together. Unit tests. The purpose of unit tests is to test each unit of code in isolation from the rest of the code to quickly pinpoint where code is and isn't working as expected. You'll put unit tests in the source directory in each file with the code that they're testing. The convention is to create a module named tests in each file to contain the test functions and to annotate the module with CFG test. The tests module and CFG test. The CFG test annotation on the tests module tells Rust to compile and run the test code only when you run cargo test, not when you run cargo build. This saves compile time when you only want to build the library, and saves space in the resulting compiled artifact because the tests are not included. You'll see that because integration tests go in a different directory, they don't need the, configure test annotation. But because unit tests go in the same files as the code, you will use configure tests to specify that they shouldn't be included in the compiled result. Recall that when we generated the new adder project in the first section of this chapter, Cargo generated this code for us. This code is the automatically generated test module. The attribute CFG stands for configuration and tells Rust that the following item should only be included giving a certain configuration option. In this case, the configuration option is test, which is provided by Rust for compiling and running tests. By using the CFG attribute, Cargo compiles our test code only if we actively run the tests with cargo test. This includes any helper functions that might be within this module, in addition to the functions annotated with test. Testing private functions. There's debate within the testing community about whether or not private functions should be tested directly, and other languages make it difficult or impossible to test private functions. Regardless of which testing ideology you adhere to, Rust's privacy rules do allow you to test private functions. Consider the code in listing 11.12 with the private function internal adder. Pub_fun add2, and then it uses internal adder. Down here, fun internal adder, it's not public. So we have function internal assert equals 4 and internal adder to 2. Note that the internal adder function is not marked as pub, but because tests are just Rust code and the tests module is just another module, you can bring internal adder into a test scope and call it. If you don't think private functions should be tested, there's nothing in Rust that will compel you to do so. Integration tests. In Rust, integration tests are entirely external to your library. They use your library in the same way any other code would, which means they can only call functions that are part of your library's public API. Their purpose is to test whether many parts of your library work together correctly. Units of code that work correctly on their own could have problems when integrated, so test coverage of the integrated code is important as well. To create integration tests, you first need a tests directory. The test directory. We create a test directory at the top level of our project directory next to source. Cargo knows to look for integration test files in this directory. We can then make as many test files as we want to in this directory, and Cargo will compile each of the files as an individual crate. Let's create an integration test. With the code and listing 1112 still in the source lib file, make a tests directory, create a new file named tests integrationtest.rs, and enter the code in listing 1113. So use adder and then test. There it is. We've added use adder at the top of the code, which we didn't need in the unit tests. The reason is that each test in the tests directory is a separate crate, so we need to bring our library into each test crate scope. We don't need to annotate any code in integrationtest.rs with configure test. Cargo treats the test directory specially and compiles files in this directory only when we run cargo test. Run cargo test now, and you'll see the three sections of output include the unit tests, the integration test, and the doc tests. The first section for the unit tests is the same as we've been seeing. One line for each unit test, one named internal that we added in listing 1112, and then a summary line for the unit tests. The integration test section starts with the line running target debug deps integration test, a big hash. The hash at the end of your output will be different. Next, there is a line for each test function in that integration test and a summary line for the results of the integration test just before the doc tests adder section starts. Similar to how adding more unit test functions adds more result lines to the unit test section, adding more test functions to the integration test file adds more result lines to this integration test file section. Each integration test file has its own section, so if we add more files in the tests directory, there will be more integration test sections. We can still run a particular integration test function by specifying the test function's name as an argument to cargo test. To run all the tests in a particular integration test file, use the test argument, the test flag argument of cargo test, followed by the name of the file. So cargo test flag test integration test. This command runs only the tests in the test/integrationtest.rs file. Submodules in integration tests. As you add more integration tests, you might want to make more than one file in the test directory to help organize them. For example, you can group the test functions by the functionality they're testing. As we mentioned earlier, each file in the test directory is compiled as its own separate crate. Treating each integration test file as its own crate is useful to create separate scopes that are more like the way end users will be using your crate. But this means files in the test directory don't share the same behavior as files in source do, as you learned in Chapter 7 regarding how to separate code into modules and files. The different behavior of files in the test directory is most noticeable when you have a set of helper functions that would be useful in multiple integration test files, and you try to follow the steps in the separating modules into different files section of Chapter 7 to extract them into a common module. For example, if we create tests common and place a function named setup in it, we can add some code to setup that we want to call from multiple test functions in multiple test files. When we run the tests again, we'll see a new section in the test output for the common file, even though this file doesn't contain any test functions, nor did we call the setup function from anywhere. Having common appear in the test results with running 0 tests displayed for it is not, having common appear in the test results with running 0 tests displayed for it is not what we wanted. We just wanted to share some code with the other integration test files. To avoid having common appear in the test output, instead of creating test/common, we'll create test/common/mod. This is an alternate naming convention that Rust also understands. Naming the file this way tells Rust not to treat the common module as an integration test file. When we move the setup function code into tests/common/mod and delete the tests/common file, the section in the test output will no longer appear. Files in subdirectories of the test directory don't get compiled as separate crates or have sections in the test output. After we've created tests/common/mod, we can use it from any of the integration test files as a module. Here's an example of calling the setup function from the itAdds2 test in tests integration tests. So use adder mod common, and then common setup. Note that the mod common declaration is the same as the module declaration we demonstrated in listing 725. Then in the test function, we can call the common setup function. Integration tests for binary crates. If our project is a binary crate that only contains a main file and doesn't have a lib file, we can't create integration tests in the test directory and bring functions defined in the main file into scope with a use statement. Only library crates expose functions that other crates can use. Binary crates are meant to be run on their own. This is one of the reasons Rust projects that provide a binary crate have a straightforward main file that calls logic that lives in the lib file. Using that structure, integration tests can test the library crate with use to make the important functionality available. If the important functionality works, the small amount of code in main will work as well, and that small amount of code doesn't need to be tested. Summary. Rust's testing features provide a way to specify how code should function to ensure it continues to work as you expect, even as you make changes. Unit tests exercise different parts of a library separately and can test private implementation details. Integration tests check that many parts of the library work together correctly, and they use the library's public API to test the code in the same way external code will use it. Even though Rust's type system and ownership rules help prevent some kinds of bugs, tests are still important to reduce logic bugs having to do with how your code is expected to behave. Let's combine the knowledge you learned in this chapter and in previous chapters to work on a project.